Hey y'all, welcome to 7.4. Today we are going to graph inverse trig functions. So, starting out, we are going to graph two cycles of f of x equals sine of x. We are doing this in degrees. So, I'm going to make this center vertical 0. And if we remember in sine of x, the period of the graph is 360 degrees. So 360 degrees for one cycle, we'll go back to negative 360 degrees for the other cycle. And then we can number the values in between. That would be 90 degrees, 180 degrees, 270, negative 90, negative 180, negative 270. And then for the parent function, this midline, this mid horizontal is at 0, and the amplitude is 1, so the graph goes up to a y of 1 and down to a y of negative 1. And sine of 0 is 0. Make sure that fact is cemented in your brain really, really well. Sine of 0 is 0, so 0 starts in the middle, sine starts in the middle and goes up. So, plotting our sine function here, this is the graph of y equals sine of x. And it does keep going. We tend to draw two cycles. It does keep going forever and ever and ever. Okay? Now, the domain and range of this graph, the domain of any sine or cosine graph, is all real numbers. It continues. The range of this graph is from its low to its high. So that is negative 1 to positive 1. Now, the inverse function. Remember, how do we find an inverse? We switch x and y. So we started with y equals sine of x. When we switch that, we get x equals sine of y. We need to undo the sign. To undo sine, we need an inverse sign. So sine inverse of this x is equal to sine inverse of sine of y. Now, sine inverse and sine undo each other. And we're left with our inverse. Sine inverse of x is equal to y. This is our inverse. Okay, this is our inverse. The relationship between x and y, it is a reflection on the graph. We switch x and y, yes, but it is a reflection over the line y equals x. It's a reflection over the line y equals x. Now, to graph this on a trig function, the line y equals x, on a trig function would be a very, very, very steep looking line right here because our x-axis is so much more compressed than the y-axis. The y-axis only goes from negative 1 to 1. Our x-axis goes from negative 360 to positive 360. Actually, it's infinite. So it's not as straightforward of a reflection as we're used to. So here's how we do this. Okay, here are the steps to graphing the inverse function. We draw a vertical asymptote at every point where y is 0. It's where the graph crosses the x-axis. We're going to draw a vertical asymptote at every point where the graph crosses the x-axis. So our graph crosses the x-axis here at negative 360, 0. Here is a vertical asymptote. Okay, at negative 180, we have another vertical asymptote, and I'm drawing these really big, really long for a reason. The y-axis is a vertical asymptote. I'm going to move this out of the way real quick. Keep you over here. Here's another at 180, x equaling 180. We cross the x-axis. And here at x equaling 360, we cross that x-axis. Now, next, between the asymptotes, we are going to mark every minimum and maximum point. Between the asymptotes, we're going to mark every minimum and maximum. Those critical points that are maxes and mins. We're going to mark those. So I'm going to put a dot here at this peak. I'm going to put a dot here at this valley. A dot at this top peak. A dot down here on this bottom peak. Okay? Then, we did that. Okay? From those max and minimum points, draw a curve the opposite direction, up or down, from the original graph, approaching the vertical asymptotes on each side. So, here's what that is going to look like. Okay? We're going to start at this section on the far left. Okay? Its peak is high. From that high peak, the graph of the regular function goes down. So the graph of our inverse function will go up. And it will go up here. Approaching the vertical asymptotes, but not actually crossing them. Looks weird, I know. Okay, so for the next one, the peak is at the bottom. Negative 90, negative 1. From that peak, the regular graph goes up. So our inverse will go down towards the asymptote, but not actually touching it. At x equaling 90, we have a high peak. The regular graph goes down from there. Our inverse will go up. And then at x equaling 270, we have a low peak. The graph goes up from that peak. Our inverse graph will go down. And that is your inverse function. Okay? Now, if you want to see just what the inverse looks like, I'm going to erase the regular function. This is what your inverse function looks like. It's just those curves between the vertical asymptotes. And here's both functions together. This graph was f of x, and then this inverse graph is f inverse of x. And that is how you graph the inverse of a trig function. Now, let's try this again. I do know why that's number 5. Okay, so we are going to draw 2 cycles of the graph of f of x equals 4 cosine 2x. We're going to label this axis here in radians. We are going to start at 0. Okay, and we need to remember in cosine that cosine of 0 is 1. So this will start at the top, wherever that top ends up being. Now, this graph has a couple things the other one didn't. It has an amplitude and it has a period. Okay, that amplitude, remember we had the graphs that are amplitude times the trig function of a b value times our x. That amplitude is the a, that's 4. That means from the midline of 0, our graph goes up 4, and our graph goes down 4. This graph also has a period. Its b value is 2. To find the period in radians, is 2 pi over b. So 2 pi over 2, or just pi. So what that means is that one cycle ends At pi, the other cycle would be negative pi. Now, in between, we have half pi's, pi over 2, negative pi over 2, and the other critical points would be a fourth, half of a half. So pi over 4, 2 pi over 4, 3 pi over 4, pi. Same thing going backwards. Negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. And remember, those are the critical points. The critical point distance is always the period over 4. So in this case, pi over 4 is how we counted those critical points. 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, pi, 4 pi over 4. And then the same thing backwards. So cosine starts high. Okay, our cycles will start and end on top. So they'll go from high to middle to low to middle, back to high for one cycle, to middle to low to middle, back to high for the second cycle. So here is the graph of our function. Y equals 4 times cosine of 2x. Okay? Now, we're going to do the same thing in order to graph that inverse. So, domain and range. Domain of any sine or cosine graph is all real numbers. The range of this graph, the range of any graph, is always its bottom to top. In this case, that's negative 4 to positive 4. So we want to find the equation of the inverse. We want to find the equation of the inverse. So we started with y equals 4 times cosine of 2x. So when we switch that x and y, we get x equals 4 times cosine of 2y. We need to undo and solve for y. We need to divide off that 4. So x over 4 will equal cosine of 2y. Now we need to do inverse cosine on both sides. Cosine inverse of x over 4 equals 2y. And then we need to divide this by 2 to isolate that y. You're going to see that divide by 2 more often as a 1/2 in front instead of a divide by 2. It's equivalent. Okay, it's equivalent. So that inverse function is 1/2 cosine inverse of x over 4. And you actually may see that as 1/4 x, 1/2 cosine inverse of 1/4 x, just to separate those coefficients. Okay. Now, what we want to do here is graph the inverse of the function we had. So, same process applies. Every place there is a intercept, x-intercept, becomes a vertical asymptote. So, at negative 3 pi over 4, we have a vertical asymptote. At pi over 4, we have a vertical asymptote. At positive pi over 4, we have a vertical asymptote. At positive 3 pi over 4, we have a vertical asymptote. And again, to draw that inverse, we find the peaks. Now, at negative pi, positive 4, this is a peak, okay? And we need to go up from that peak. There is another half, okay? There is another half of that inverse. It's off our graph because it wasn't in the cycles that we graphed originally, but it's okay. Okay, do the same thing at negative pi over 2. We have a peak there. We go down from that low peak. At 0, 0, comma 4. We go up from that peak. At pi over 2, we'll go down from this peak. And at pi, we go up from this peak, and it would go up on the other side. So here is your inverse function. And here's your inverse function with the regular function. All right, guys, that's graphing functions. Bye, y'all.